All right, so let's try to solve. Let's continue to solve this problem. This is again a linear programming or linear optimization problem. Let's see how do we do that. So here we have an objective function which is z is equal to 3x minus 2y, and we have constraints number 1, that's x between 1 and 5, and y is greater or equal to 2, and I have x minus y greater or equal to minus 3. As we have been doing, I don't like whenever I have y to be negative, so I'm going to rewrite this in terms of y to be positive. So if I do that, this would be transformed into something like this: y is less than or equal to x plus 3. All right, so now we have three constraints that we are going to work with, and then see how do we do that. So the first one says the x is between 1 and 5. So let's go with that. For that one, let's go with the green. So this is x is between 1 and 5. So here's my 1, x is equal to 1, and here's my x is equal to 5. The second constraint is y is greater or equal to 2. So here's the line y is equal to 2. So therefore, it's going to be everything on top, right? So it's going to be everything in between, the first constraint. Second constraint says everything in here. So it's going to be just this part, these two conditions, these two together. Let me change the color for this one so it's easier to see. Let me go with this color there. So let's change it. It's not really that color, but all right, let's go with that. And let's take a look at the third condition. Third condition is y is less than or equal to 3. So let's try to graph this line y is equal to, let's try to graph this line y is equal to x plus 3. So when x is equal to 0, y is 3. When y is equal to 0, x is minus 3. So here is the point. That is x is minus 3 and y is 0. And when x is equal to 0, y is 3. So the other point is right here. So if I make a line, that line is going to be this right here. All right, I did not do a good job there. I did not do a good job in that line. So let's see, I think it's going to go to, no, it's going to go to 8. All right, so here's the line right there. So therefore the domain or the region of interest is going to be this one. Let me just shade it. So if I shade it, you see that it's going to be this region right here. All right, that will be the region. And the points that I'm interested in this case, is going to be the points that I'm interested in are going to be these ones. Let me change the color. Let's go with the light blue. So it's going to be this, 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 and this, right? So these four ones are the ones. Now, what are these points? These points are, as you see here, these points would be, this is x is 1, y is 2, and this is x is 5, y is 2, and this is x is 5, y is 8, and this is x is 1 and y is 4. So we have four points there. So we got all those 4 points. Again, if I go back to the steps, we are right here. We found the constraints. It's already given to us as an inequality, and now we are trying to we graphed them, and then now we are looking at the shaded region, and then we just found the corners or the vertices. Let's go back to table and then try to figure these things out. Let me move this one out a little bit so that it's easier for me. So what I have here is I have my x comma y. I have 4 points, and I have my z, which is equal to 3x minus 2y. You know this also over here. And let me take these points. If I take a look at the 1 comma 2, that's going to give me z is equal to 3 times 1 minus 2 times 2, which is going to be negative number, right? That's going to be a -1. And I go with 5, comma 2, my z is going to be 3 times 5, which is 15, minus 2 times 2, which is 4, which is going to be 11. And the third point is 5, comma 8, so therefore my z is going to be 3 times 5, which is 15, minus 2 times 8, which is 16, which is going to be a -1. And I have 1, comma 4, and then therefore z is going to be 3 times 1, which is 3, minus 2 times 4, which is 8, so it's going to be -5. So if I make a table, right, and here are the values in here. Here's my table right there. And my maximum is going to be 11, and the minimum is going to be 15. Right, the maximum is 11 and the minimum is 15. So we can say for this function, the maximum is equal to 11. That happens at 5, comma 2, this one. And the minimum is -5, which happens at this particular point right there. So that's how we would solve these kind of problems. So let's take a look at another problem. And then it's a word problem. So let's see how do we solve this. So here are 4 steps in solving this. Let's go through each of these 4 steps and solve this optimization or linear programming problem. A student earns $15 per hour for tutoring and $10 per hour as a teaching assistant or teacher's aide as a TA. So X is the number of tutoring hours and Y is the number of hours as a TA. The question is how to write the part A is write down the objective function. So very simple for the total weekly earning, right? So how much is going to make? The amount that he's going to make, let's call that as a Z, is equal to, he's going to get $15 for every X number of hours he spends in the tutoring. So it's going to be 15 times X plus, and he's going to get $10 for every Y number of hours that he spends as a TA. So that's all we have as the function there. Here are some conditions. The condition is the student can work no more than 10 hours per week, right? So which means both X and Y together. He cannot work more than 10 hours. So it's going to be X plus Y has to be less than or equal to 10. The tutoring center requires that each student spend at least 3 hours per week. So which means that the X should be minimum. If you sign up for the job, you have to spend at least 3 hours per week. So it's going to be X has to be greater than or equal to 3. It also says the tutoring center requires that each tutor spend no more than 8 hours per week. So that means that X has to be again less than or equal to 8. So if I put these two restraints, if I put these two, all these conditions together, all these restrictions or conditions or restraints or constraints together, then I'm going to have X plus Y less than or equal to 10, and X has to be greater than or equal to 3 and has to be less than or equal to 8. So here is my objective function and here are my constraints. So let's see how do we use that to figure the maximum amount of money that I can optimize, so that maximum amount of weekly earning, right? Let's try to optimize that. So we're going to do the same way we did earlier. Let's write down these. So we have 2 conditions. The two conditions are, and there are a couple of things, by the way, I don't have to tell you this. These are some basic common sense. That is, the number of working hours has to be greater than or equal to 0, okay, right? It cannot be negative. So we can add these 2 conditions if you want, that X has to be greater than or equal to 0 and Y also has to be greater than or equal to 0, right? The number of working hours, you can't have a negative working hours. So that's a common sense. So that tells you this one and this one, right? These 2 together tells you that X has to be positive and Y has to be positive. So it's going to be in that region, right? It's going to be in that particular region. And then we have these 2 equations to work with. So let's try to write down these. So X has to be positive and Y has to be positive, right? And then X is between, not only that, X is between 3 and 8. So 3 is right here, 3 is right here, and 8 is right here. So X, the number of tutoring hours have to be between 3 and 8. All right. And the third thing is the other condition is x plus y has to be less than or equal to 10. Again, the y is positive. I like that, so I'm just going to keep it like that. When x is equal to 0, as you see, y is going to be 10. If you look at that equation, and y is equal to 0, x is going to be 10. So let's write that down. So it's going to be, let's go with a different color. Let's go with a blue. So here we have when x is 0, y is 10. It's right here. When y is 0, x is 10. It's right here. So it's going to be this particular line right there. All right. So what does this line looks like? So it looks like the region that I'm interested in is going to be this particular one. Right? That's the region that I'm interested in. And the corners are, these are my corners. 1, 2, 3, 4. So if I write down the values for these corners, it looks like here I have x is 8 and y is 0. And here I have x8 and y2. And here I have x to be 3 and y to be 7. And here I have x to be 3 and y to be 0. So I have 4 corners, right? I have 4 values there. Now let's try to figure out the maximum value the student can earn. So here I'm going to go with, again, just like we did earlier, let's go with the x comma y values and then the amount of earning possible with all of these. So what does this mean? Just by the way, this means that students get to work 3 hours into tutoring, 0 hours as a TA, 8 hours in the tutoring, 0 hours as a TA, 8 hours as a tutoring and 2 hours as a TA, 3 hours as a tutoring and 7 hours as a TA, right? So those are the ones that's going to make it the best or the worst case scenario. All right, so let's take a look. When it is 3 comma 0, that is tutoring is 3 and the TA is 0, your z, which is, by the way, a 15x plus 10y, that's a 15x plus 10y, is going to be 15 times 3 plus 10 times 0, which is going to be $45. And let's take a look at 8 comma 0. Obviously, this is a better salary. This is a better weekly earning. So z is going to be 15 times 8 plus 10 times 0, right? Which would be 15 times 8 is 80, it's 120. And let's take a look at the 8 comma 2. 8 comma 2 would be z is equal to 15 times 8 plus 10 times 2, which is 120 plus 20, which is 140. The last option is 3 comma 7, so which is z is equal to 15 times 3, which is 45, and 10 times 7, which is 70. 70 plus 45 is 115. So the best case scenario, as you see right here, would be this particular one. If the student works 8 hours as a tutor and 2 hours as a TA, he'll make the most money. If you want to barely keep the job, if you want to do the bare minimum, he can work, 3 hours. He can work 3 hours as a 3 hours as a TA, so 3 hours at the tutoring center, so that he satisfies the conditions. And that way he will make $45, right? So therefore here the maximum possible earning would be $140. That if he works 8 hours at the tutoring center and 2 hours as a TA. And that's how we solve these problems. I think I already worked this out already, right? We already set this up. Here's our objective function, and here are our constraints. So I let you work this out on your own and tell me what you get as the solution there. Again, also try the it's your turn problems too. That's all, ladies and gentlemen. This takes care of the chapter 5. And so basically now we know how to solve systems of equations, systems of linear equations, and how to deal with nonlinear equations and systems of nonlinear equations, inequalities and systems of inequalities, and then using that, how do we solve linear programming or linear optimization problems. All right, I will stop it right here. So that's all we have for you. Have a great semester, have a wonderful career.